Hooke's law. What is it? Hooke's law can be shown using the formula F equals K delta L, where delta L is the deformation, K is the constant, and F is the force, or the restoring force. As a constant, K depends on the shape of the object, the composition of the object, as well as the direction of the force. It can also be written as delta L equals F over X, where X now is the constant. Here is an example of a human slingshot to better break down the parts of this formula. Here you can see the arm is holding down the slingshot, which creates the deformation, which then creates the restoring force above it. Once the arm lets go, the force pulls the object back towards its stable equilibrium, where the net force is 0. The momentum causes the slingshot to move back and forth across the equilibrium. This motion is called an oscillation. An oscillation is a regular variation in magnitude or position around a central point. In other words, it can create a wave or disturbance that expands from its origin point, or its equilibrium. This motion continues until dissipative forces decrease the momentum. Another example is a trampoline. Oscillation for a trampoline is going to look just a little different than that of the slingshot. So, to start off, we have our wavelength like normal, which is the same as the slingshot. However, in the slingshot, our equilibrium was closer to the center of that wavelength. That's not the case for the trampoline. The trampoline is closer to the top of that wavelength. The reason for that is because the springs in a trampoline actually are very resistant, making the trampoline not be able to use all of its restoring force when it comes back up, and only go a little bit past that equilibrium. So where does the rest of that restoring force go? Well, when we jump on a trampoline, we are the force that's pushing the trampoline down. Well, the rest of the restoring force is from here up. And because the trampoline gets stopped here, the rest of that restoring force is put into the person. And that's why when we jump on a trampoline, we get pushed farther into the air past where the trampoline stops. Because the rest of the restoring force that's from the trampoline gets pushed into us. That's why the farther down we jump, or the harder we jump on a trampoline, the higher up in the air we're going to go. So there you have it, Hooke's law.